Hello guys, in this tutorial I'm going to solve question number 7, paper 52 March 2024. Find the number of different arrangement of 9 letters. Without any restriction, when I ask you to rearrange 9 letters, if they are different, will be 9 factorial. But in case if there are repeated letters, you have to divide it by their factorials. Like what? D is 2 letters divided by 2 factorial. E, 3 letters divided by 3 factorial. This is the final answer. You can simplify it. This is without restriction, but we have more than restriction in the question. In which 3 E's are together? Stop. We have 3 E's, E, 3, and we have D, 2 letters repeated, and 1 L, 1 I, 1 V, 1 R. If you count now, will be 9. 3, 2, 5 plus 4, 9. In how many ways we can rearrange in a line? Where is E's together? E's together, consider it as a 1 letter. So 1 and 1, 2, 3, 4. 4 plus 2, 6. Now will be 7. Will be 7 factorial divided by, there are 2 D's, so to repeat it, 2 factorial. In case if 3 together are same, no need to multiply by 3 factorial. But if it is different, you have to multiply by 3 factorial, which represent their arrangement. But it's our same, so please don't try to multiply by 3 factorial. Now, this is the first part, in which 3 is together and have to condition both. And the 2 D's are not next to each other. We can solve it by getting all the cases where is together and minus all the cases is and the D's together. So I will now explain in case if is together and the D's together. So as 2 letters, and we have 4 left, so will be 6 factorial. Divided by, no, because now is together and the D's together, so there is no repeated. And the is are same, so no need to multiply by 3 factorial. This is the final answer. Then find your answer simplified will be 101,800. Again, 9 different will be 9 factorial. 9 with 2 repeated and the 3 repeated will be 9 factorial divided by 2 factorial into 3 factorial. But is together combined is a 1 letter, so we have 7 factorial divided by 2 factorial. To get all the cases where is together and the D's not to next each other, so you can subtract all the cases where is D's together and the D's together to get all the cases is together and not these together. This is the final answer of part A. In this part, you can take is as a 1 card together like this. And letter D, sorry, D is not together, so keep it away now. We have letter L, I, V, and R. In how many ways we can rearrange in a line? 1, 2, 3, 4, 5. So it's a 5 factorial. 5 factorial. No need to multiply by 3 factorial of is because are same. Now it's a 5 factorial. In case if these is not together, so 1, 2, 3, 4, 5, 6. There are 6 places and we'll select any 2. Will be 6C2. If you try to write 5 factorial and write 6P2, you will select, then arrange. For the first case, because arrangement are same, so I will not multiply by 2 factorial. The second one, if you select 6P2, it's included select and rearrange. But we have to repeat it. This is why you have to divide it by 2 factorial. If we try to get the calculation of the first one, it's 5 factorial multiplied by 6C2. So the answer will be 1800. Second one, 5 factorial multiplied by 6P2, then your answer divided by 2 factorial. So you will get the same answer, 1800. Part B, find the probability. When I ask to get the probability, randomly, arrangement of 9 letters, stop, you have to get the denominator. The denominator will be without restriction. In how many ways we can rearrange in a line? It's a 9 factorial divided by 2 D's repeated and the 3 E's repeated. So this part have to be the denominator. So you can get the total without restriction first and get the number. Will be 9 factorial divided by 2 factorial into 3 factorial. This will be the denominator, 30240. This is the total randomly arrangement without any restriction. Has exactly 4 letters between 2 D's. Let's start the first case. If let's say we have letter D, then 4 places in between, 1, 2, 3, 4, and again letter D, then 3 left, 1, 2, 3. This is the first case, but I will shift D instead. I will leave the first one. Then we have here D, yeah, 1, 2, 3, 4, then letter D, then 2 left. Repeat again, we have a space, then D, 1, 2, 3, 4, then letter D, then 1 left. The last case, 1, 2, 3, letter D, 1, 2, 3, 4, then letter D. We have now 4 cases. So if you rearrange this case, D, space, and we have 7 letters left. In how many ways we can rearrange 7? It's a 7 factorial, but these 7 included 3 are repeated, so divided by 3 factorial. This happened for how many times? 1, 2, 3, 4. So multiplied by 4. Get this answer will be 7 factorial divided by 3 factorial multiplied by 4. So you will get 3360. So the final answer to get the probability will be fraction 3360 divided by 240. Simplify your answer. Divided by 30240. So the answer will be 1/9. So the final answer simplified. Part C, 5 letters are selected from the 9 letters the word delivered. Find the number of different selection if 5 letters include at least 1 D and at least 1 E. We'll select 5 from 9. But we have repeated. There are 2 points. We have already D, 2 letters, and E, 3 letters. We have 3 letters, and we have here 1. And there are 4 different letters, which is L, I, sorry, we have here 2 D. We have L, I, V, and R are different. Now we want to select 5. In how many ways? But it's written at least 1D and 1E. Let's now start to write all the cases. First, maybe 1 from D, 1 from E. How many left to complete the group of 5? There are 3 left. Maybe 1 from D, 2 from E, then 2 from different. Maybe 2 from D, 1 from E, then how many left to be 5? It's 2. Maybe take 2 from first, 2 from second, then 1 from the third. Maybe take 3 E's. In this case, we can take 1, then how many left? Or we can 2, so how many left? Zeros. Let's now write all these cases. The first case, 1, 2, 3, 4, 5, and 6. The first one, 1 from D. Don't try to say 2C1. It's our same. Leave it. Don't try to say 3C1. We already will take one of them. They are the same. Just we'll write here 4C3, then find the answer. It will be 4 times 3 divided by 3. So 4C3, this is the first case. It's exactly like 4C1, so the answer here is 4. Same, don't try to say 2C1 or 3C2. Just write 2 directly. It's 4C2, which is equal 4 times 3 divided by 2. You will get 6 cases. The next, same, 4C2, you will get 6 cases. Then 4C1, you will get 4. 4C1, you will get 4. And 4C0, you will get 1. Find the total. 4 plus 6, 10, plus 10, plus 5. So the total is 25. You can show your work out that we have letter E, then letter D, and there are 1, 2, 3 left. We'll select it from the front 4, will be 4C3. Then maybe 1 from each, maybe there are E1 and there are D2. So D and D, there are 2 left. We'll select it from 4. We can switch and take T, 2 E's and 1 D. So how many left will be 2? We can take 2 from each, 2 E's and 2 D's. It's okay. So how many left is 1? We can take 3 E's, 1, 2, 3, and 1 D and 1 different letter. Or we can take 3 E's and 2 D's. So we have 1 case. Find their sum, we will get 25 cases. Thank you.